Hello, Algebra 2 folks, and welcome to logs graphing. So yesterday we learned about logarithms and how they help us isolate the exponent. Now today we're going to learn how to graph them and what they look like and how they are related to exponents. Okay, so you need your pen or a pencil, a calculator, and 3 pieces of graph paper, and we will get started. All right, so let's think back to exponential functions. This says y equals 3 to the power of x. What we did is we plugged in -2 to 2, and we graphed this function. So we would get -2.11, -1.33, 0, 1, 1, 3, and 2, 9. And we would graph this, and it would look like an exponential growth graph. Remember, the domain was all reals. The range was greater than 0. And the asymptote, remember, because there's no shifting up or down, the asymptote was y equals 0. All right. So that's what we did when we talked about exponential functions last week. Today, we're going to graph log functions. Okay, but in order to do this, our calculator really doesn't like log base 3. It doesn't really like log base of anything but 10. So what we're going to do is we're going to learn how to rewrite it in exponential form. Well, guess what? We already know how to write it in exponential form. So what I'm going to do is I'm going to move stuff around in this equation to kind of help it make it look a little better. First and foremost, f of x equals y. Oops, sorry about that. F of x equals y. So I'm going to say the y equals the log base 3 of x. Now I'm going to go ahead and write it so it looks like this. Log base 3 of x equals y. To me, this makes it easier. When the y is on the right-hand side, it's easier to put this in exponent form. So remember, we learned that yesterday. 3 is the base. Y is the exponent. So this would say 3 to the y power is equal to x. Now, how is that different than what we just did? If we go back, we did 3 to the power of x. Now we're doing 3 to the power of y. What did I do with my x's and y's? I interchanged them. And that means I have an inverse function. So logs are an inverse to exponentials. That's pretty cool. So what I'm going to do with my table is, remember, we could put anything we wanted to in the x value of the exponent. Now the y is in the exponent. That means our y is all reals. Okay, so we can put anything we want into the y's. It also means that if our x's and y's are interchanged, our table can be interchanged. So now, instead of x being -2, our y is -2. And when I plug -2 in for y, I'm going to get 0.1111. When I plug in -1, I'm going to get 0.3333. 0. And my x value is going to be 1 now. If I plug a 1 in for the y, I'm going to get a 3 for the x. And then when I plug a 2 in the y, I'm going to get a 9 for the x. So now when I plot these, it'll be 0.111, -2, 0.333, -1, 0, 1, or 1, 0, 3, 1, and 9, 2. And now my graph looks like this. I bet you anything, if I graph the y equals x line and I graph the exponential, I would get a reflection. All right. So now let's look at this. When I'm looking at this problem, there is no shifting horizontally, okay? So the asymptote is going to be 0 if I don't have anything being added to my function or subtracted from my function. My graph is horizontally is not going to be shifted. So now the asymptote is up and down. So now the asymptote is x equals 0, and my domain is x such that x is greater than 0. So all my roles for domain and range and asymptote have completely flipped. So when I look at that, and I'm going to look at that right now so we can compare them. There's a comparison here. We know that they are inverses of each other. So with exponential functions, we knew that the domain was all rails. Now what we know about log functions is that the range is all rails. And we usually knew that the range was y such that y is either greater than or equal to the asymptote. Okay, because it could be greater than or it could be less than the asymptote. Now the domain is x such that x is either greater than or less than the asymptote. And the asymptote is on an exponential is a y is equal to. And now the asymptote on the log is x is equal to. And so here is my exponential function, what's graphed in blue. Okay, and here's my log function. And when I have y equals x, it means that they're going to reflect over y equals x. So if I folded down over y equals x, they would fold on top of each other. So they are inverses of each other, which makes them pretty cool. And it's really easy to graph exponents, or it's easier to graph exponents. And so if we take all our logs and put them in exponent form, it's going to make graphing logs so much easier. Okay, let's try a couple more now that you've seen how exponents and logs are related. So I always take my y and put it in for f of x. That's the first thing I do. The second thing I do is I always like the y on the other side. I don't know why, but I'm just kind of crazy like that. I always feel like this is easier to get it into exponent form. So it would be 3 to the power of y, because remember, logs isolate the exponent. So 3 to the power of y is equal to x minus 4. Now, in order for me to graph this, I need x alone. So I'm going to say 3 to the y plus 4 is equal to x. Now this plus 4 is going to be a shift in the horizontal direction. And that's important with logs because that tells you the asymptote. So 1, 2, 3, 4, my asymptote is going to be x equals 4. My range is going to be y such that y equals all rails. And now my domain is going to be based on my asymptote and whether I graph on the right-hand side of it or the left-hand side. So let's take a look. If I were to plug some values in for y, I would use -2, -1, 0, 1, 2. The reason why I would use those values is because the y doesn't have any shifting. So because the y doesn't have any shifting, I'm just going to go ahead and use -2 to 2 for y, just like I did for x. And now, remember, the 4 tells me that I've shifted my asymptote from 0 to 4. Okay? And now if I were to plug -2 in for there, I would get 4.111. And then if I plug -1 in for there, I would get 4.333. 0 would give me 5. 1 would give me 7. And 2, if I put 3 to the power of 2, I get 9, and 9 plus 4 is 13. All right, so now I go to 4.11, which is about here, and I go down to -2. 4.33 down to -1, 50, 71, and 13.2 is kind of out here. I'm not going to graph it, but it'll help me get that curve, and I will see I have a nice shape. Okay, I need to have that curve shape, and now all my values are greater than 0 on the domain, so my x is x such that x is greater than 4. Okay, let's try one more. All right, again, always trying to get these in exponential form. So y equals 5 plus log base 3 of x. I'm going to rewrite this as 5 plus log base 3 of x equals y. Okay, in order for us to write this in exponential form, what you need to know is that it's always important to get the log base of whatever that is alone. So we have to get this alone. So we have to get that 5 to the other side. So I'm going to subtract 5 from both sides. So I've got log base 3 of x equals y minus 5. Now that my log is isolated, now I can put it in exponential form. So the base is 3. Oh, but now my power is y minus 5. So this is all of my exponent now. Okay, so I'm going to put that in parentheses so that I remember to do that when I plug it into my calculator. And that will equal x. All right, now, is there any shifting horizontally for the asymptote? No. So the asymptote is x equals 0. Okay. So x equals 0. So I'm going to go ahead and draw that in. Okay, my range is all reals because I can put anything I want into my y's. So my range, I would usually use -2 to 2, but remember we've got the shifting now in the exponent. And because we have some shifting in the exponent, we are going to add 5 to all the values to the -2, to the -1, to the 0, to the 1, to the 2. So we're going to add 5 to all of those. So -2 plus 5 would give me 3. Okay, and -1 plus 5 would give me 4, and then 5, and then 6, and then 7. So I really need to make sure that I do that so that I can see that curve. If I don't see that curve that's happening, then I'm going to be in trouble. So if I plug a 5 in, I am going to get, okay, let me back up. If I'm going to plug a 3 in, 3 minus 5 is -2, and 3 to the -2 is 0.11. Then if I plug a 4 in there, 4 minus 5, I'm going to get a -1, and 3 to the -1 is 0.333. 5 minus 5 is 0, and 3 to the 0 is 1. And 6 minus 5 is 1, and 3 to the 1 is 3. And 7 minus 5 is 2, and 3 to the 2 is 9. And so those are my new values. Okay, so I'm going to go 0.111 to the 3, 0.333 to the 4, 1 goes to the 5, 3 goes to 6, and 9 goes to 7. And what you're going to see is I still have that curve, but it shifted up. My shift went up. So So see, because I shifted in the Y, it went up. When I shifted in the horizontal, it moved left and right. Okay, so shifting is still going to happen, and that's kind of important. Remember that you need to know your asymptotes. You need to know that your range now is all reals. And now the domain for this one is x such that x is greater than 0. It's still greater than 0 because my asymptote is what's reflecting my domain. Okay, that's all, folks. And we'll see you tomorrow to practice.